Hello everyone. In this video, we will learn about the first two laws of thermodynamics, which are important concepts that help us understand how a system can change during different processes. There are four fundamental laws of thermodynamics that explain the behavior of energy and matter in the universe by making a framework for understanding energy and heat flow in various systems. Let's explore each law. The Zeroth law of thermodynamics states that if two systems are in thermal equilibrium with a third system, they are in thermal equilibrium with each other. To understand this law, it is important to know what is thermal equilibrium. Heat is always transferred from an object with a higher temperature to an object with a lower temperature, and this heat transfer stops when the temperatures of both bodies become the same. At this point, no net heat is transferred between bodies, and when no net heat is transferred between two objects in contact, the two bodies are in thermal equilibrium with each other. Now, imagine there are two glasses of water named A and B, and both are in thermal equilibrium with another glass C. The Zeroth law of thermodynamics states that since both glasses A and B are in thermal equilibrium with a third system, which is glass C, they are in thermal equilibrium with each other. What is the first law of thermodynamics? The first law of thermodynamics states that the total energy of a system remains constant, while it can be transformed from one state to another or transferred from one place to another through interactions with heat, work, and internal energy. In other words, this law states that energy cannot be created or destroyed. It just changes from one form to another, which is another expression of the law of conservation of energy. When a system changes from a given initial state to a given final state, the work done and the heat transferred can vary depending on the specific characteristics of the process. But the difference between the heat and work is constant for all processes. This quantity is dependent on the initial and final states of the system and is independent of the specific process during the transition. Q alone and W alone and all other combinations of these two are dependent on the path, but the amount of Q minus W is the same. According to the first law of thermodynamics, changes in the internal energy of the system when it has transformed from one state to the other is obtained using this relationship. Q is the amount of heat entering or leaving the system, and W is the work done on the system or done by the system. Also, internal energy, heat and work are measured in joules in the above equation. Q minus W represents a change in an intrinsic property of the system, and we call that internal energy. You should pay attention that here, the work done on the system by its surroundings is considered negative, and the work done by the system on the environment is considered positive. When heat enters the system, thermal energy is absorbed by the system, so Q becomes positive. And when the system loses thermal energy, Q becomes negative. If energy is added as heat, the internal energy of a system tends to increase. And if energy is lost as work done by the system, the internal energy tends to decrease. Let's use an example for better understanding. This cycle shows the process. A gas in a closed container goes through. And it is a given that the energy added as heat during constant volume process AB is 30 joules. During process BC, no energy is transferred as heat, and the net work done during the cycle is 20 joules. We should find the energy transferred by the system as heat during the constant pressure process CAB. As we see in the picture, the process is a complete cycle. It means the initial thermodynamic state and the final thermodynamic state are the same. So the change in internal energy must be zero. As we mentioned, that it is only dependent on the initial and final state of the system, which hasn't changed. So delta E is zero. On the other hand, it is equal to the subtraction of heat and work. From this equation, we get that the heat absorbed by the gas is equal to the work done by the gas. So the amount of heat during the process C is equal to 20 joules minus 30 joules minus 0 joules, which is minus 10 joules. The negative sign means that these 10 joules of energy is transferred away from the gas as heat. We came to the end of this video. I hope that this video has provided valuable insights and expanded your knowledge.